Dear learners, we are going to see about scheduling algorithms in CloudSim in this session. The topics which we are going to cover are the core components of a CloudSim architecture, the various scheduling algorithms, how the simulation to be taken up in a CloudSim environment, how you can able to customize your scheduler part, and what are the various dependencies that accompany for your CloudSim application deployment, and how we can able to interpret your results. Moving on to the core components of a CloudSim architecture, we have various components. First one is a CloudSim, which is going to initialize and manages the simulation part in the cloud environment. And we have the real infrastructure that it can able to be configured in a cloud environment. The infrastructure is going to be a data center, simulating a cloud data center. The host that can able to represent a physical server in terms of the configuration of CPU, RAM, bandwidth storage, and we have virtual machines that run user tasks. So user tasks are obviously known to be a cloudlet. User task or job to be executed in a cloudlet. And you have data center broker, which is going to be mediated between the users and the data center and handles the scheduling part. The VM allocation policy, where the policy for allocating the virtual machines to host has been incorporated using this component. And the cloudlet scheduler is going to accompany the policies for scheduling the cloudlets on a virtual machine, which is going to be time shared or it is going to be space shared. So when you're going to use multiple users, multiple small tasks that you are going to run it, you can able to have the time shared. For a small set of processes, you can able to adopt the sharing of resources to it. But whereas in a space shared, you're just going to have a single file to be executed at a single point of time. So for a batch files, you will be normally preferring for a space shared. Moving on to the scheduling algorithms, where these scheduling algorithms have been taken from the foundations of the OS operating system. First come, first served. Here, as of in a CloudSim, the cloudlets user job are executed in the order they arrive. In a round robin, each user job gets an equal amount of time slice in turns to complete its task. The next one is a shortest job first, wherein the cloudlets, the user task with the shortest length are executed first. According to the length of its execution, each and every task takes its own set of resources for its process to be completed. The next one is a priority scheduling, where tasks with higher priority are scheduled first. The next one is the simulation flow in a CloudSim environment. Beginning, you have to initialize the CloudSim environment. You are supposed to set infrastructure configuration. The infrastructure configuration is creating a data center. You can able to create a broker. You can able to create host and virtual machines. You can create the cloudlets, the user task. You can submit the virtual machines, the instances and the user task to the broker. Once you have been configured this, you can start the simulation and you can find out the results of each and every task that has been completed on its own. You can be able to retrieve the results. Once all the results has been returned, you can able to stop the simulation, fetch those results and interpret those results, analyze the results. When coming to the custom scheduler implementation, which means that if you want to implement your own scheduler algorithm, you may need to extend or overwrite it. So where you can able to overwrite it? So you can able to overwrite by making use of the extends that particular interface to your own class. So your own class is my broker. You're just going to extend the interface that is your data center broker. It's going to be interface. In this interface, you are just going to override the scheduled task. This particular method has been overwritten. Here, you can able to update the lines of code of your scheduling logic. Not only the data center broker, you can also extend VM allocation policies also to have the customized virtual machine to host assignment. And the dependencies, when you're going to integrate it in a simple application in a CloudSim environment, what type of environment do I need it? So when I'm going to integrate it in Java, we can able to adopt either NetBeans or Eclipse. I have been used Apache IDE environment, NetBeans environment. And the jar files that are mandated for execution of CloudSim code is CloudSim sim.jar and math comments math, these jar files are mandated. And the output of this particular code is going to be the cloudlet results, which can able to generate the cloudlet ID, start time, finish time, and the status. So from these results, cloudlet results, you can able to compute the performance. So what type of performance metrics we can able to compute? Like you can able to find the total span of its execution of the process, and how much time it has been executed, each and every user task, how much time it takes for its execution, how much time it has been waited for, what is the throughput, and how much resources, what are the resources that has been utilized. So these you can able to have an analysis part from the output. So as of summary, we have been find out the core components of a CloudSim architecture. We have been seeing the various scheduling algorithms. We have been gone through the simulation flow in the CloudSim environment, and we can able to customize your own scheduling logic in the parts of lines of code. And what are the various dependencies that are accompanied when you're going to adopt this CloudSim application, and how you can able to interpret the results.